What's going on YouTube? Coach Carr here bringing you another video. Now this one is on the page 4 and 5 in your notes, so I hope you enjoy. So the success criteria is you'll be successful when you can find shaded portions of a sector and the circumference of a circle. So it's kind of a two-parter in here. And the learning targets arrive using similarity, the fact the length of the arc intercepted by an angle is proportional to the radius. Okay, so the problem we're looking at, page 4, number 10. In this one it says, in the diagram, the central angle of the unshaded sector measures 60 degrees, and the radius of the circle is 9 pi centimeters. Find the area of the shaded region. So main thing here is we are trying to find the shaded region. Now the unshaded part has a degree of 60 degrees. So that would be the unshaded part. The radius is, so that line that goes from the center to one of the sides of the, or the outside of the circle, is supposed to be 9 over pi. So if I'm trying to find the shaded region, the angle I'm going to use is not this 60 degrees. It's going to be this part over here. So the full circle is 360. So if I did 360 minus 60, I get 300. So the unshaded region is 300 degrees. So when I use the equation of the angle times pi r squared all over 360, the angle that we're going to use is 300. The radius that we're going to use is still going to be this 9 over pi. So when I do this, I get 300 times pi, and my radius is 9 squared, but remember that this is over pi. So we have 360, and then it was 9 over pi. Now, when you have this, I have a pi in the numerator, pi in the denominator. That actually can cancel out. So now, when I do it, I would have the 300 times 9 squared, which is 81, all over 360. And when I multiply these together, 300 times 81, I get 2,400. Oh, wait. So 24,300. Divide that by 360. And that's going to equal 67.5 centimeters squared. So the next problem is number 11. It says in the diagram the radius of the outer circle is 12 centimeters. The radius of the inner circle is 9 centimeters. And the angle AOB is 90 degrees. What's the area of the shaded region to the nearest tenth of a square centimeter? So the first thing I recommend with this is label the things that we're told. So I'm told that this angle is 90 degrees. That's one of the things I'm told. Now, the first thing up here, the radius of the outer circle is 12 centimeters. So from O to R, that's 12. That's supposed to be 12 centimeters. Now, the distance from O to the inner circle is 9. So from here to here, that's 9. So when we are go to find the shaded region, we're actually going to have to find the area of both the smaller one and the bigger one. So both are going to use the formula the angle times pi r squared over 360. So I'll just put them each here because I'll end up finding both. So first one, let's do the small circle first. So for the angle, I'm going to use 90 degrees times pi. Now the radius is supposed to be 9, so I'm going to have 9 squared all over 360. So when I do this, when I square 9, I get 90 times pi times 81 all over 360. When I multiply 90 and 81, I get 7,290 pi over 360. When I do that division, I get 20.25 pi. So that is the area of the small sector here. So now the next one will be the full thing, or not the full thing, but the full sector. So again, I'm using 90. So 90 degrees times pi. The radius for this one is 12, so times 12 squared, all over 360. So 12 squared is 144. So I got 90 times pi times 144, all over 360. Multiply 90 with 144. I get 12,960 times pi, all over 360. When you divide this, you get 36 pi. So the whole point of doing that is to find this shaded region. So this is what we're trying to find. So what I want to do now that I have the full sector and the sector of the smaller circle, I'm going to subtract both of them. So when I do this, 36 pi is going to subtract with 20.25 pi. When you do that, you end up with 15.75 pi. And since they want us to round to the nearest tenth, that means that I actually want to make this pi into a decimal. So 15.75 is going to multiply with 3.14. When I do that, you get 49.455. Now, they said the nearest tenth. The tenth is 1 decimal place. So the only thing that can potentially change is the 4. So when I do this, I have a 5 right next to it. So if it's 5 or higher, round up. So I want to make sure we don't forget this from back in the day. It's 5 or higher, so we're going to have to round up. So I have 49.5 centimeters squared for that shaded region. All right, so what to do? We're on page 5. So we're going to be looking at number 14, but before we do that, we're dealing now with circumference. So if you're dealing with circumference, That's the length of the entire circle. So if I were to take a circle and lay it out, it's how long it would be. So the formula for circumference, there's two ways that we can do it. Either with d times pi. So d stands for diameter. And a diameter would be the full length from one side of the circle to the other. The other way is with 2 pi r. So basically you're multiplying the radius by 2 to get a diameter and still multiplying it by pi. So those are the formulas we are going to be using when we do these problems. So let's look at, again, number 14. This one says the radius of a circle is 3 over pi centimeters. What's the circumference of the circle? So again, circumference is supposed to be equal to 2 pi r. Since they gave me the radius, that's why I used this one. Now, when I do this, c equals 2 pi, and the radius they gave me was 3 over pi. Now, I have a pi in my numerator, and I have a pi in my denominator, so that actually makes it so they cancel out. So what I really have is 2 times 3, so the circumference in this case is going to be 6 centimeters. Alright, home scale, it's the last problem on this page that I want to do is number 16. Now this says Eric's new tricycle has tires with 18 inches diameter. How many complete revolutions does his wheel make during a 1 mile ride? Now, remember that a diameter is if you have a circle and you go across the full length. So the full length would be 18 inches. So this full length is 18. So since they gave me the diameter, I'm going to use the formula that we did above where we say c equals the diameter times pi. Now, in this case, the diameter is 18. So 18 times pi. Instead of pi, I'm going to make it 3.14. And when I do that, I get 56.52 inches. So that is the amount of inches in circumference. So if I took this circle, put it out in a straight line, it would be that long. So in order to figure out how many revolutions it needs to make in a 1 mile ride, we need to do some conversions. So one of the conversions that's actually given to you on the EOC reference sheet is that there is 5,280 feet in 1 mile. That is a conversion that you have and is given to you. So since this is in inches, I'm going to go ahead and turn it into feet. So the way that we do that, so you have 56.52. If I divide that by 12, that's going to tell me how many feet this is. So that means when I divide it, I have 4.71 feet. So using this, if it's 5,280 feet in 1 mile, if I divide it by 4.71, because that's how long it is in circumference, I get 1,121.019. So that's how many revolutions in 1 mile. See, aren't you glad you know this kind of stuff? Thank you so much for watching. Make sure to like, subscribe, and do all that jazz.